Gas tungsten arc welding, stainless, deck 1, process basics and setup. So what is gas tungsten arc welding? Gas tungsten arc welding is when we use a non-consumable tungsten electrode. Tungsten's a metal and it's got an insanely high melting point. So we can run a ton of electricity through it, current through it, and use it as an electrode, and it doesn't melt and turn into our weld puddle. We don't deposit weld metal from that. So we use a separate filler metal separate from our electrode. And this is different than most other welding processes where our electrode is also being consumed and it's our filler metal. And we usually use an argon shielding gas. We can use other gases such as helium, but we need an inert gas when we're going to use gas tungsten arc welding. This protects our non-consumable tungsten electrode. It also protects our weld puddle from oxygen and nitrogen. So why do we use gas tungsten arc welding for stainless? We can use other processes. Well, gas tungsten arc welding is clean, it's precise, it gives us really precise welds, there's no spatter, really good control, and it protects the corrosion resistance of the material. So for basic equipment, you've got the power source, you've got the torch and the tungsten, our non-consumable tungsten electrode, and up in that upper right hand corner you can see our, there's different ceramic cups, and we've got the collet that holds the tungsten, our non-consumable tungsten electrode, and the ceramic cups. I think I mentioned that. Well, you've got the whole TIG torch set up there, and we need an argon gas supply, and this is I snagged this out of a U.S. military manual, so great place to get content. But anyways, here's a good shot of what the basic TIG setup looks like. So here you can see the parts of the torch. Torches for TIG welding, these are going to be different than other processes because most other processes don't have a non-consumable tungsten electrode. So we can get a lot of different types and sizes. We can get big water-cooled ones. We can get smaller air-cooled or gas-cooled. So the two things that the torch does is it's going to carry electricity to the weld puddle, and it's going to carry shielding gas to cover that weld puddle because oxygen and nitrogen are not our friends, and they're trying to get in there and damage or corrupt our weld puddle, our stainless steel weld puddle. So you can see we've got the nozzle here, which is usually ceramic, and I think there's some other, weird materials that the nozzle can be made of. You can see the collet body and the collet. They're what hold the electrode, and electricity, electrical current, flows up the cables into the TIG torch and into the collet and collet body, and then that electricity flows on into our weld puddle. So, and if the manual torch, they're gonna have a handle so that the welder can manipulate them. That just makes sense. Power sources for welding machine. This is where we get the electricity. So we take some current, some amperage, some voltage from a supply, the power line or the power company or however that magically gets to us, and then it's going to turn it into a usable current. We're going to take 230 or 460 volts of input power, and then we're going to turn it into the amperage and voltage that we need. We're going to go from 230 or 460 volts of input electricity into maybe 20 amps and 100 amps and 20 some volts. We're stepping it down from whatever we're intaking, but we get a usable, controllable quantity of electricity going to our weld puddle through our non-consumable tungsten electrode. So we've got different types of welding current. We've got direct current, pulsed current, alternating current, and high frequency current. So direct current, This is the one we're mainly going to talk about. But this is like, a car battery. The electricity just goes one direction. It's just like a loop. Direct current, we're going to send it through conductors, our welding cables and our ground cables. So, this is like a big battery sending us direct current, and it just goes one direction. This is different than alternating current, which I don't really understand, but I understand it, but how it goes both directions to me is one of those mysteries of the universe. But direct current we're going to use for most materials that are not aluminum. That's what we use direct current for. Anything that's pretty much not aluminum. We use alternating current for aluminum because the alternating current busts up the oxide that forms on the surface of the material, or the weld puddle. So that's why we use alternating current there. It gives us some stuff that direct current doesn't. So when we're talking about direct current, we've got two different ways we can run the electricity. We can go electrode positive and electrode negative. So if we're using electrode positive, when we're doing that, if we go electrode positive, what happens is 70% of the heat is in the electrode and 30% of the heat's in the base metal. So you're going to get a pretty wide, shallow penetration. But this might be what we're wanting if we're welding some thin material like, beer can material. And I know that's a generalization or, a gross over exaggeration, but some thin materials, we don't want deep penetration. Well, if we go DC electrode negative, which is also straight polarity, we're going to get a narrow melted area, and about 30% of the heat's going to be in the electrode and 70% of the heat's in the base material. And you can see here, if we're using the DC electrode positive, we're going to have a really large tungsten electrode so we can soak up a bunch of heat. So DC electrode negative. So we're focusing the heat in the work. And this is standard for stainless. So AC we're going to use with aluminum, and DC electrode positive we're going to use when we weld really thin materials. So now that we've got our understanding of our basic equipment, we've got a general idea of the power source, what kind of current we're going to be utilizing. We understand a little bit about the torch and the function of the tungsten. We got a little bit of knowledge about the argon gas supply. Well, let's talk about the shop setup, the reality of stainless. What are we welding? Stainless. Well, the thing with stainless, or any TIG welding, what you're welding is going to be different. And I know that sounds stupid in the way I just phrased it, but if we're welding titanium, we're going to have to approach that completely different than we approach welding stainless. If we're welding carbon steel, we're going to have to approach it different than how we're welding stainless steel. So then it's going to ask questions of what are we really doing? Are we going to do this on a bench? Are we going to do it in a position, or is it going to be in a pipe rack or something, or a skid where we're welding this stuff? We're going to need the torch leads, and we're going to need grounding. How are we going to ground this thing? Where are we welding this stuff? And we're going to have to deal with, gas flow. How are we getting gas to our torches? But just these are some things that we need to talk about, but they aren't the focus of our little module here. So with that being said, let's say we have something set up and we're welding stainless. Where can it go wrong? And this is what we're going to focus on for the next couple slide decks. Poor cleanliness, no purge, too much heat. And we haven't touched base on those things yet, but we will. So the bottom line, when we're welding with gas tungsten arc welding, it's going to give us control. Stainless is unforgiving, and setup is going to matter. And we're going to talk about that later on.